Hello, we are the Cryptos group, and in this lab we are going to talk about how to crack passwords with John the Ripper tool and using the dictionary attack. In order to do this lab, we are going to use Kali Linux. In this exercise, we are going to see the content of the files shadow and password. With the next command, we are going to see the content of the shadow file. If we analyze one user, we can see that there are different fields separated with two dots. The first field is the name of the user, the second one the password, the third one is the days from the last password change. The next two fields are the minimum and the maximum number of days between password change. The next one is the number of days of warning before the password expires. And the next files that here doesn't appear because this user doesn't have it, but are the number of days before the password will be inactive, the number of days before the account expires, and the last field is a field reserved for other options. Then if we take a look at the password file, we can see the same users, but now with different fields. The first one is the name of the user, the second one is the password of the user, the next is the user ID, in the case of the root is 0, the next one is the group ID, which is 0 in case of the root. Then we have a description, which is usually used to write the real name of the user, in this case root. The next is the home directory of the user, and the last one is the default shell for this user. If we want to create a user, we have to use this command, and the name could be hello user, for example. And then we are going to define a password to this user by this way. Now, if we take a look again at the files shadow and we go down, we can see here the user we have just created with the hash of the password we have just created. Then, if we go to the password file, we are going to see at the end the user we have just created with all the fields. And finally, with this command, we can see the hash used for the password. We introduce a password and it says to us the hash of this password. And then if we want to see the hash of the password of the hello user, we can see it too. Now we are going to decrypt the password we have just created for our user with John Ripper. First of all, we copy the content of the shadow file in a shadow file, for example, and the content of the password file in a file called password, for example. Then we merge both contents in one file with the unshadow command. And then we execute the John Ripper by this way. We can see that one password hash has been loaded. In order to see which password is, we only have to enter to the file where all passwords decrypted are saved. And here we can see the hash of the password of our user and the password decrypted. Now we are going to make a dictionary attack, and obviously first of all we need the dictionary, which is a file that contains a lot of passwords. If we execute the John the Ripper to the file we have just created, syspasswords, with that command, using the option word list, in order to use that dictionary. Here we can see that the password of the hello user, which is the user we have created, is 1234, and we also.
Hello, my name is Ivan Lago, and I have to explain the exercise number 7, which talks about the hybrid attacks. Here, the first step is to create a dictionary related with football terms. So here we have the dictionary we created, and well, it appears words like Messi, Cristiano Ronaldo, Ronaldi, and so on. If we try to do a first approach as a decryption, we can do something like that, and we recover two passwords, as we can see here. Get this 90 and this Messi theory. On the other hand, the exercise says that we can find some rules in order to substitute some words or some letters by special characters, or even use the john.com file that is defined by default. So if we put this command, just adding these rules single, we see that we have more passwords recovered, as we can see in fact in this john.pod file, and here appears more passwords. So obviously these new added rules helps us in order to get more passwords. Okay, that's it. Hello, my name is Ivan Lago, and I have to explain the exercise number 7, which talks about the hybrid attacks. Here, the first step is to create a dictionary related with football terms. So here we have the dictionary we created, and well, it appears words like Messi, Cristiano Ronaldo, Ronaldi, and so on. If we try to do a first approach as a decryption, we can do something like that, and we recover two passwords, as we can see here. Get this 90 and this Messi theory. On the other hand, the exercise says that we can find some rules in order to substitute some words or some letters by special characters, or even use the john.com file that is defined by default. So if we put this command, just adding these rules single, we see that we have more passwords recovered, as we can see in fact in this john.pod file, and here appears more passwords. So obviously these new added rules helps us in order to get more passwords. Okay, that's it.
Hello, my name is Daniel Pons, and I'm going to show you the step number 6 of the lab 3. We have got a file which is a dump of MySQL table, including the structure and the data. Our hash candidates are MD5, SHA-1 and SHA-256. The column secret has 40 hexadecimal of length, and the password column contains 32. Using this table provided, and knowing that one hexadecimal are represented by 4 bits, we can determine that that the password field contains MD5 hashes and the secret field contains SHA-1 hashes. Now I'm going to feed these secret hashes to the web crackstation.net, which contain 15 gigabytes of words. Here the result. So this website has been able to decrypt all the input hashes. Now we are required to use salted passwords. First, in the handout, there are an example about the SHA of the two almost equal words. That's Velociraptor 1 and Velociraptor 2. If we make the SHA hash of these two words, the output are completely different. So, why of this behavior? Because hashes are the product of cryptographic algorithms, and these algorithms takes parts of the input and make operations. If we change some values, at some point all the output will be different with no relation between other inputs. Again, I'm going to use the crackstation.net trying to decrypt these passwords that we know they are solved. So doing this, I'm expecting that the dictionary of Crackstation will have the words with the solved at the beginning of the word. If not, no decrypt will be possible. And this is the result. Now this website has not been able to decrypt any password. So let's try with HashKiller, and this is the result. Now this website has been able to decrypt all the inputs. In this case, the three first numbers as a string are the salts stored in the database. Now, using the words text file provided, I'm going to use John the Ripper to determine the passwords by a brute force. And after some tries, we have not been able to specify a parameter that would allow us to tell format of the input, which we know is MD5 of the salt plus the word. So we have decided to use another option that John the Ripper has, which is create a new dictionary from another with some new rules. Our new rules are that the three first characters of the word will have the new salt. So before this recording, I have added the rules in the John the Ripper file configuration. And in this section is possible to add own rules with a specific syntax that we have learned from the online documentation. If we type numbers beginning and separated with this symbol, and very important, with an inverse order, they will be replaced in the output file. Our salts are, in this case, 632 470 101 642 987. So now we can type John the source word list, that's words with our new rules, to the standard output, printing it to this file. So with this we have a new dictionary with all the previous words, but with the new possible salts at the beginning. I mean these, all the previous words with the possible salts that we have in the file. For example, for the 4101 and for the 470. So now we can execute the command that we have learned during this lab to decrypt raw hashes. Format raw MD5 with the new word list created, and in this file on the MD5 I got only the MD5 hashes from the database. So now we can see that all the passwords has been decrypted with no problem immediately. Hello again. In this video I'm going to show you the result of the last exercise. We have tried to decrypt passwords from the strongest password file. Before I start the process, I have downloaded the biggest dictionary that Crackstation has. It is about 15 GB of data. After 18 hours, I have aborted the session due to the delivery deadline. The session has used this dictionary and these single rules that John the Ripper has, making the most letters common changes. And this is the result. With this information, we know that the password from user 1 is the word password 93 with these character changes. The same with user 14, with user 17 and user 19. But what is the problem? John the Ripper has tried to decrypt the LM passwords, I mean the second column of the file. But this decrypt tells us the characters and the proper order, but we have not any information about the upper and the lower case. To know something about that, it is necessary to decrypt the third column, which contains the NTLM passwords, but we have not enough time to do it.